Hello everyone. Uh, Today we are going to solve this question. It's from 2024's ICPC Latin America Championship, and I would recommend you should first give it a try. Okay, this question. I'll provide the link in the description. Okay. Now I'm giving spoiler. Okay. So the spoiler is the tag for this question is bipartite graph. Okay. Now, after this spoiler, if you want to try it, okay, like you'll have idea that it's bipartite graph problem. You have to just think about the approach, okay? You can try it, else we can start now, okay? So the question says, okay, the restaurant operates as follow. Okay, we have a restaurant which follows the concept of stacks, okay, where the last customer is served first, okay. So if there's a queue and whoever will be the last in that queue will get served first. Okay. Now the restaurant operates as follows. There is a single line inside the restaurant. When the customer enters, they immediately join the back of the line. And whenever stack of placed pancakes, okay, like someone is baking the cakes, and whenever cakes are ready, then it will be served as the person at the back of the line will get the first, and that way the distribution will start from the last of the line. Okay, like whoever entered last will get the first. So this business is successful. Okay, and now they are offering two types of pancakes. Okay, glazed and savory. Okay, now there are two lines. Okay, one for each type of pancake. Each customer joins the back of the line corresponding to the type of pancake they want. Okay, whenever a stack of glazed pancake is ready, it is served to the customer at the back of glazed pancake line. Okay, consider like that we have two shops. Okay, one is for uh, pancake type 1. Okay, and some people are standing in that line in that store. Okay, for that type 1 pancake, and there's another type 2 of pancake, savory pancake. Okay, and it has a different queue. Okay, there are two lines, people are standing there and they want pancakes. Okay, so now what we have, you want to ensure your employees follow the concept and maintain your vision. Okay, we have to follow that rule, stacks rule. Whoever enters last will get the first. Okay, given the order in which customers come in and out of the restaurant, you need to determine whether there is an assignment of customers to lines such that stacks concept is followed. Okay, like now consider like this, we have two lines. Okay, and come consider, okay, I'll show the test case here. Okay, here you can see +2 says a second, like a second person enters in a line. Okay, then +1 says a first person, person number 1 enters the line. -1 says person 1 left the line, and -2 says second person left the line. Okay, so what we have to do, we have to distribute those people into lines such that they are following the stack rule. Okay, like here, okay, I'll take this example and try to show you how we can do it. Okay, I'll explain it. So here, so see this. Okay, now what we can say, what was it, +2, then +1, then -1, then -2. Okay, so here we have two shops. Okay, one is G, one is S. Okay, two types of pancakes. So what we can say, two person entered here, first person entered here, first person left, second person left. Okay, So for this input, we managed to put them in such type that they are following stacks concept. Okay, now here you can see, okay, here you can see both both are going for the same line. Okay, can we do this? See, we can do like this. Okay, we have only G. Okay, plus 2 enters, plus 1 enters, minus 1 left. Okay, last person gets served first, then minus 2, then okay, see, this is following that stack concept. Let's take another example from input. uh, Plus 1 plus 2 minus 1 minus 2. See, plus 1 plus 2 minus 1 minus 2. Here see, we have G, we have S. Plus 1 goes here, plus 2 goes here, minus 1 here, minus 2 here. This is following that stacks concept. See, whoever enters last gets served first. Whoever entered last gets served first. Okay, let's try a failing case. Okay, plus 1 plus 2 plus 3 minus 1 minus 2 minus 3. Okay, plus 1 plus 2 plus 3 minus 1 minus 2 minus 3. See, we have only two shop G and S. Okay, plus 1 enters here, plus 2 enters here. Now we have to put 3 somewhere else. Say we are putting here plus 3. Okay, okay, what we can do, we'll put plus 3 here. Okay, we have here plus 3 minus 1. Okay, now see, if we put minus 2 here, the first person gets served first. Okay, plus what the actually what we need, we have to serve third person first. So the requirement was minus 3 should get here, but what are we getting here? Minus 2. We can't put minus 2 here because that person entered in this line now. So for this sequence, we don't have any what we can say, we can't put that sequence into two shops. Okay, like a line can't be formed which will follow the stacks rule. So the answer will be, we have to print here just star. Okay, now we'll try how we can solve this problem. Okay, see what we can do. Let's try some big case. Okay, first we have to think a right case. See what we have now, plus 1 plus 2 plus 3 minus 1 minus 3 and minus 2. See, this case is right. Okay, we can assign, we can put these people into shops such that it will follow the stacks rule. Okay, now what we'll do, we'll consider only two person. Okay, P1 and P2. See, we have two people. Okay, P1 and P2. From those two people, what we can say, if in of P1, then in of P2, then out of P2 and out of P1. Okay, like first P1 is getting in the line, then P2 is getting line, then P2 is getting out of the line, then P1 is getting out of the line. Okay, this is our first condition. Another condition, what's possible? Another condition, a person 1 is getting in, a person 1 is getting out, person 2 is getting in, person 2 is getting out. Okay, what can be our third condition? Person 1 is getting in, person 2 is getting in. Now person 1 is leaving first, and then person 2 is leaving. Okay, now see this. P1 enters, P2 enters, P2 leaves first, then P1 leaves. Okay, if we have this condition, then P1 and P2 can go to the same line. Okay, we can say that. Okay, if a P1 enters before P2 and leave the line after the P2, we can say that this P1 and P2 can be the part of the same line. Okay, now see the second condition. P1 is getting in the line, P1 is left. Okay, like he was the only in the line, he left. Then P2 enters the line, he left. Okay, see, those are the separate, they are not affecting each other. Okay, so this case is also possible. Okay, this also follows the stacks rule. Now see this condition. P1 enters, but it left the line. He left the line before the P2. Okay, and P2 left the line after the P1. Okay, this is not following the stack. So stack rule. Okay, whatever the rule is. So this is not possible. So what we can say, if we have these two conditions, they belongs to the, oh, my handwriting. Okay, okay. Those people belong to the same line, same queue line. Okay, and if this is the condition, they can't be in the same line. If we put them in the same line, then it will not follow that rule. Okay, it will not follow the stack rule. Okay, the boss wants to apply that rule. Okay, and we have to say, is there possible at least one arrangement to do this? Okay, so if this case is there, we have to, they belongs to the different line. Okay, now what we can see here, see, if this case exists, what we'll do, we'll add an edge between P1 and P2. Okay, we'll add edge between P1 and P2. And here comes the logic of bipartite. What bipartite graph says that, okay, if you are new to bipartite graph, you know basic of graph, I'll explain it. Okay, see. So we have graph. Okay, consider we have graph 1, 2, 3, 4, 5, and 6. What the bipartite graph concept says? Okay, graph is bipartite if we can, if we made two sets of the nodes. Okay, two non-empty sets of the nodes, such that the on whatever edges we have in that graph will from the set 1 to set 2 and set to the set 1. Okay, there will no there will be no edge between set 1 to set 1. Okay, this case will not be there. If this is set 1, this is as set 2. See here, what I can do, I can put this first node in S1, then this in S2, this is in S1, S1, S2, and this in S2. See, there is no edge exists between a node belongs to the S1 to S1. See, okay. So this is the concept of bipartite, and how we code it. What we do. This is the same as the coloring problem. We try to color the nodes such that two adjacent nodes will not have the same color. Okay, and we do this by taking only two colors. Okay, so what we can do here. See, we'll add the edge between P1 and P2. So see, if take this consider this case. Okay, if there's edge between 1 and 2, it means that 1 and 2 person 1 and 2 can't be part of the same line. Okay, that person 1 and person 2 will not be the part of the same line. Okay, so what we'll do, we'll add him in one uh, line 1. Okay, G, and this one in S. Then from here also we can't put 2 and 3 in same line, 2 and 5 in same line. So we'll put in line of G. Okay, that whatever the name was of that pancake. Okay, started from G, and after here we'll add this in S line, this in S line. So it's possible. Okay, now let me take the case where it fails. See, like after making that graph. Okay, if it looks like this, 1 2 3, this. Okay, if we put person 1 in G line, then we have to put S, sorry, 2 in S line. Okay, now the problem is where we'll put this 3. Okay, it can't, we can't put him in G and S also. Okay, so for such cases we have to print star, because there will be a no sequence. Okay, so what's the conclusion here? See, you can clearly see it. Okay, in bipartite graph. Okay, it's a general problem. Okay, of bipartite graph, that okay, it's known as same name, like bipartite graph, else even odd length cycles to coloring problem. Okay, see, whenever there will be an edge which is of size odd length. Okay, here you can see this is the cycle of three edges are there. If even there exists only one odd length cycle, then we can't make a bipartite graph from it. Okay, and if all cycles exist are of even length, then can only we can say that graph is bipartite, and we can divide all nodes into two sets. Okay, now we'll try to do it. Okay, how we can do, see what problem we have here. Okay, I'll erase everything. Okay, I think this is enough. See, uh, see constraints. What are constraints? We have only 1000 constraints. So what we can do, we can go for like n square time complexity. It's okay. Okay, we can go for n square time complexity. Now with what we'll do, we'll travel will traverse for n square time complexity and find out such edges. Okay, see, we'll check for 1 comma 2. So one enters first, then second enters, but first guy leaving first and then second guy. Okay, it's not following that rule. So yes, we have age between 1 and 2. Now 1 and 3. 1 is entering first, 3 is leaving first, 1 is entering first, 3 is leaving first. So yes, 1 and 3 also have that age. Now 2 is entering first, then 3 is entering, but 3 is leaves the line first, and after that second is leaving the line. So see, it's following that rule. So there is no age between 2 and 3. No age. Okay, these are the only possible things. So what we'll do, we'll have age between just 1 to 2 and 1 to 3. So we'll give g to the 1, then we'll go to the 2, we'll give s to 2, and then here we'll give s to the 3. Let's try to draw it. Okay, here this is g, this is s. Okay, plus 1 goes here. Okay, now plus 2 goes here. Okay, now where we have to add plus 3? Here in s. Plus 3 enters, minus 1, sorry, 1 left, so this is minus 1, minus 3 left, 2 left. See, this is how we have to solve this problem. Okay, first we'll go for n square, we'll find such edges, and after that we'll apply simple bipartite graph. Okay, if the like condition for bipartite graph, if the graph is bipartite, yes, we have sequence, and if um, we find we have any cycle which is of odd length, else we can say if the graph is not bipartite, the answer will be like we have to just print star. We can't make an arrangement here. So let's try to code it. Okay, see what are given, n, and we have 2n length of input. See, oh, where is the question? Okay, what it says, first line consider integer, and okay, the customer number will be from 1 to n. Okay, 0 I is less than 2 into n I plus plus. Char c, since c. First we have to take that character. Okay, is it entering or exiting the line? Okay, after that int x sin x. Okay, that number. Now what we have to do, we have to in and out vector of every number. Okay, let's make it. Okay, now we have vector of in of size n plus 1 and out of n plus 1. Okay, if c equal to plus sign, in of x will be I, else out of x will be I. Okay, now what we have to what will be the next step? We have in and out vectors for all people. Okay, now we have to travel on people. Okay, and we have to check for every people with all other people that do they belong to the same line or not. Okay, the three condition we saw last time. Okay, let's see, can I undo? Okay, this condition we have to just check for this condition. If this condition exists, we are going to add an edge. Okay, so for int I equal to 1, I is less than equal to n I plus plus, for int j equal to I plus 1, j is less than equal to n j plus plus. Okay, so okay, we'll make the graph first. Okay, vector of vector and plus 1. Okay, we need to make graph. So what we'll do, if f of I comma j, we'll check for this condition. Okay, in f we'll check for this condition. If this condition is true, what we'll do, g of I dot push back j and g of j dot push back I. Okay, I'm writing a lambda function here. Okay, auto f equal to and okay, now what condition we have, if p1 is entering first. Okay, let's say x is entering first, and after that x2 is so y is entering, but x1 left first. So if in of x is less than in of y, and in of y is less than out of x, and what we can say, x is entering before y and y is entering before x, and then okay, let's put some condition here, x and okay, out of x is before out of y. I think these conditions are enough. Return true. Now there will be another condition also. Okay, we check for x and y, considering that x is entering first. What if y is entering first? Okay, we are just pushing those values in this graph. Okay, we actually don't know how they are coming here in input. You can see, where is the question. Okay, see here, plus 2 was there. Okay, after that 1 was there. So what we have to do, we have to check in a both way. So same we have to do for y also. In of y is less than in of x, and in of x is less than out of y, and out of y is less than out of x. Okay, return true, else we have to return false. Okay, now till here what we have got, we form the graph. Okay, now we have to check is it bipartite. Okay, so we'll write another lambda function. In bipartite we require only two things. Okay, first is the node and the color. Okay, here we need two arrays. Okay, first will be vector of bool, which will be the visiting array. If we already visited that node, we are not going to visit it again. Okay, and plus one, and another is vector which is of color. Okay, color, and return will be f of, we are starting from the node 1, and we are giving color 1 to the node 1. Okay, now in this what we'll do, we'll visit the node. Then what we'll do, we'll assign the color to the node. So color of node will be the color. Okay, after that we'll traverse on the children of the node. Okay, g of node, and now if we never visited that child, okay, we'll go on that child. So we'll check is it possible to add such colors, alternate colors from that child. Okay, here we'll get that return value. Okay, so what will be the function here, dfs of it, we are going on it, and what will be the color. Okay, see how we are going to do it. 1 2. Okay, we want these two colors. If I pass one color, okay, now I have to convert it into 2, and if I pass two color, and then I have to convert it into 1. Okay, like when I reach the node with the color 1, I have to pass 2 to the next node. Okay, whatever children that node have, we have to pass color 2, and if the node have color 1, color 2, the node has color 2, we have to pass 1 to the all children. Okay, see how we can write it, 3 minus color. Okay, 3 minus color. So if it's not possible, return false. Okay, another condition we have to check, else if. Okay, so we already visited the children, but the color of that children and the node is same, it's not possible. What we'll do here, color of it, okay, equal to c color. Okay, if this is the case, return false, not possible. This is the children. Okay, it has some color because we already visited it, we already gave it the color. Okay, if this color is same as the color we gave to the node, and they have the age, okay, they both have they share an age and they have the same color, so it's not possible to uh, con- uh, like it will not be the bipartite graph, and we can do a two color problem here. Okay, like adjacent adjacent node have the same color. Oh, here we'll do return true. Okay, see, considering that this is enough. Okay, see, if we got yes, okay, like true. So what does it mean? That like we have a sequence here. What kind of output we want? Okay, so what we'll do, for int I equal to 1, I is less than equal to n, I plus plus. If I equal to 1, cout g, else cout s, and we'll print new line here. Okay, and in else condition it's not possible. Okay, it's not possible, so we have to print just star in this case. Okay, let's try it. Let's try it on some given cases. Okay, what's the problem here? We have to debug it. We need to debug it now. Mm, okay, one case we were missing. Okay, like what we have to do, we have to run loop from n, and in this will be the code. Okay, with some changes. Okay, of course with some changes. See, we'll start from the I. Okay, if we already visited that node, we'll continue. We'll not check for that node again. Okay, now we don't need this. We have to. Okay, if at any point it returns false. Okay, if at any point if it returns false, then we have to print star, and will return from this void solve. Okay, now after visiting all nodes, if there is no like there is no such problem where two adjacent nodes, okay, which are sharing edge have the same color, we can say that this graph is bipartite. Now we'll print it. For int I equal to 1, I is less than equal to n, I plus plus, cout, okay, color of I equal to 1, question mark, cout g, cout s, and after it cout slash n. Is it syntactically right? Yes, I think yes. See, okay, it's still giving star. Let's try another cases. We'll debug it. Basically, still star. Okay, what's the problem? Okay, so the problem was we were considering the graph one base indexing, but here we were using zero base indexing for in and out vectors. Okay, Ah, what's the problem here now? Okay, so the problem was I was calling f function. Okay, I was calling this function all this time. Okay, this is also right. Let's try to submit it. Okay, okay, I already solved it like few days ago. Hmm. Okay, this is the solution. I'll try. Okay, I'll put this submission link. Okay, this code in description. Okay, that's it. Okay, this was one of like this was a simple problem. Okay, it wasn't that hard. The hardest part was that finding out that is here we are going to use the application of the bipartite graph. Okay, this was from 2024 ICPC Latin America Championship, and literally so many people were unable to solve this question. Okay, that's it for today. Thank you.